let's go through this. So you covered some of this already, Nicholas, but let me just give you a sense of it. So by a historical quirk, we're actually headquartered in Mazda City. We were very lucky earlier on that when the Abu Dhabi government was putting in place a lot of the framework around IP and patent protection, etc., that one of the ways that they felt that they wanted to promote innovation was to bring a makerspace to Abu Dhabi. So it was a very pioneering move at the time, made by the Technology Development Committee, and that's how we end up in Masdar City, and we operate in our different locations around the world from there. This morning I'm joining you from Dublin. And then we have colleagues who are based in Valencia in Spain, in Munich, Washington, D.C., Sydney, and in Kansas City, plus a lot of other collaborators. So we're trying to really promote this on a global basis. In terms of the company, effectively what we're bringing to the table is a full turnkey delivery of makerspaces. So the client can be a government, corporate, it could be at the innovation and entrepreneurship level. Universities are groups that we work with an awful lot. And essentially we're designing makerspaces anywhere from 30 square meters up to the largest size we're doing at the moment is 4,500 square meters. So they come in all shapes and sizes, and effectively what we're bringing together is all of the components to deliver such a project. Here's a list of some of the clients that we're working with. We've had a lot of success in the automotive sector, dealing with people like Ford. Ford are probably the pioneers in using makerspaces. Initially just as a tool to gain traction within their own community of engineers, to get people working across an organization, where you have, let's say, many thousands of engineers. How do you get them to collaborate on projects? How do you get that interdisciplinary piece going? So, as I say, Ford were the leaders in that, and then other organizations like BMW, Audi, the Korean and the Japanese manufacturers have followed in their line as well. So there's a whole range of people coming to this, and effectively what they see in a makerspace is a blank canvas. And just in the way that Miloš has been talking about the way that he's applied it to his work, effectively they're finding this as a way to solve problems for themselves or start to explore potentially maybe new areas of business. So what is a makerspace? So the model was developed originally like that for a gym or an exercise area. It's membership based, and the membership based thing is quite critical. It's behind trying to create an identity for people who self-identify as makers, and essentially try to give them a third place, somewhere they can go, where they can call their own, and where they're meeting with like-minded people. That's one of the main drivers behind the membership-based model. The other component then is that it's also trying to drive down the cost of access. This is a very kind of social facility, and what we're trying to do is make the access as low cost as possible to make sure that we're bringing back people on a continuous basis, and again helping to build out the community. And it's the technology extension of DIY. I mean, we all do it. We're all forced into doing levels of DIY, and as Miloš again has shown here, we're adding layers of technology onto the existing hand tools that are familiar to most of us. And again, it's sharing and collaborative. That theme will repeat itself throughout the presentation. I think it's the most powerful piece of a makerspace is the fact that you have like-minded people working there, and you can effectively find ways to collaborate and gain experience from others. It's all about technologies, companies, products, jobs, and entrepreneurship creation. People come with an idea. People come with just some germ of an idea, or something far more developed in the way that Milosh has. But it's a safe place in which to start exploring your initial ideas. And what we're seeing is that you have people who, again, in the self-identification, like working with other people. We see companies develop out of that, but then also a range of products and services coming through. So it's a meeting place for lots of different people. If it was only for engineers, begging all of your respective pardons, it would be a terribly boring place if it was only for engineers. So we actively work to ensure that we get about 20 to 25% of artists and disruptors coming into the space. You need that input. You need that, you need people coming and asking the crazy questions. Why are you not painting that pink? Or why is that edge square? Why aren't you making it rounded? You need a multidisciplinary team in all of your making projects. You need them to look good. You need people to help you communicate the ideas. And as I say, this list of students, teachers, artists, manufacturers, dreamers, and the dreamers are the important people. They ask the crazy questions, but out of those crazy questions come potentially powerful ideas. So as I say, we're trying to create this rather unique space for all of these different folk. So let's just talk about the maker movement. The maker movement has had a whole series of iterations. So I talk about maker culture. So maker culture is a branding exercise. It talks about pursuits and processes that go back into prehistory. We've always made things. We've always communicated how we made things. That's how tools were created in the first place. That's how they were iterated. But the real change in making has come around at about the same time that Google was started back in 1996. So we probably have about 25 years of the maker movement at this point. And these prototyping tools and technologies that we now have available and that have rapidly evolved, especially in the last decade, that's what's empowering the maker movement. And effectively, what we've taken away is the fear factor of using machines. They are very simple and very easy to use. We are focusing a lot on getting kids as young as 7 and 8 in using things like laser cutters, 3D printers. So anyone can use them. The time investment is quite limited. And really, it helps you to start explore either in your personal life or in your work life a whole series of new ways of doing things. And we're also finding that makers are the engine of the economy. They are creating multiple types of SMEs with access to really, really powerful tools. And this is why government especially is really focused on makers and the power and capabilities that they bring. So this slide is interesting in terms of, if you like, the segmentation. What do different audiences, what do different groups see in makers and the potential of making? So advanced manufacturing is becoming one of the key areas around making. Advanced manufacturing is typically low volume, high value manufacturing. And that's something that a makerspace is ideally tied into. You have, for example, in Australia, it talks here about trade skills and workforce development. In Australia, they've cut out the traditional layer of manufacturing. So, for example, all of the car industry is now gone. So as a national economy, they're throwing their weight behind advanced manufacturing. But they don't have the people to work in that industry. So they have a fantastic trade skills organization called TAFE, and they're now starting to look at how do you use a makerspace as a way to give hands-on skills and practical knowledge to people who are going to work in advanced manufacturing. So that's just one particular cohort. In the education side and training, governments, the example that I think is most impressive is in Germany. Germany has always had this dual track in terms of university education and the apprenticeship model. That's been a bedrock of the country over the last number of years. But what they realized about 5 years ago was that advanced manufacturing and making essentially needs people with a combination of that blue collar and white collar skill. So they're actively working towards integrating STEAM and STEM into their curriculum so that they will be developing and delivering for industry the engineers that are required. I think we're also seeing right throughout the Emirates and throughout the GCC that all of the education bodies are starting to integrate STEM in the curriculum. And that's an absolute recognition that we need to be creating new types of graduates, giving people new types of skills, etc. So what we like to say is that Makerspace transforms lives, entrepreneurism, neighborhoods, communities, and the economy. It's powerful, it's pervasive, and we have lots of examples where we can demonstrate how this works. Let's try and talk about prototyping. So what Milos showed earlier on was pretty advanced prototyping. Somebody who's at the top of their game, who knows how to use the software, who knows what the capabilities are. But a lot of times, I think what we say to people is, before you start using the machines, let's use pen and paper, let's use cardboard, and let's figure out what it is you're trying to do. And what we're trying to do is engage the brain. What we're trying to do is engage people's thinking in terms of what's the journey that you're going to do. You have the idea, you know where you want to get to, but what's the starting point? What are the intermediate steps that you need to get along that journey? And as I say, very often what we try to do is ask them to look at things in cardboard, in paper, mapping out what the journey should be. And that helps them to really understand what it is they're trying to do. So again, cardboard is really, really powerful, and it helps people engage with their process. So let's just quickly talk about different kinds of makerspace. So here in this makerspace that I'm showing on the screen is one that we created for the automotive industry. This is a location in Melbourne, Australia, and it talks about trying to integrate different components of the organization. So here we have people who are mechanical engineers, who are electronics engineers, people who are doing software design, electronics design, but then there's also the marketing folks involved as well. There's the senior management. So this space on the left side, the ideation was essentially where everybody came together, where effectively different ideas were socialized effectively in terms of what the organization was going to put its resources into for the coming 3 and 6 months. And again, in the way that it brought together the multidisciplinary components of the organization, it was a meeting place. The rest of the space then, as you can see on the right-hand side, was, for example, a car lift, so you could fit various pieces to the car. You had fabrication in the area behind, etc. So the idea of a makerspace, what I'm trying to convey here is effectively, it's not just an area for work. It's an area where you need to allow people to have a cup of coffee, just to sit around area to chat, and really kind of do team building across the project. Let's go to the slide. So how does a makerspace work? You know, what are you doing? How do you put it together? How do you create it? So open access is the key to all of this. Whoever comes in the front door of a makerspace, whether they're highly skilled or have zero skill, we believe that we have to create the environment where people can learn at their own pace, and can learn as much as they feel they need to do for their particular project. Others will want to learn about every particular machine that's there. They will want to, do a complete deep dive. The makerspace essentially is to allow people to come in, figure out where they want to be at their point in their life or in their career, and adapt it accordingly. So open access is one of the critical factors in all of this. In terms of designing a makerspace, so we talk about hard arts areas and we talk about soft arts. So the border here that's described by the red line essentially says anywhere south of that red line, a child of 8 years and up can come into that space and work cleanly and effectively without being a danger either to themselves or to any of the other people working in the area. So that's a critical factor. It's one of the key things that we look at in creating the space. Then where we have, from a health and safety point of view, machines which are more complicated, which can hurt or injure people, they're north of that red line, and they're typically access controlled. So there's badge access, and you can't get into those spaces until you've effectively proven that you have undergone the safety training and the specific machine training as well. So we distribute we create this working area, the green, that spine in the middle effectively is the circulation space, and you will often see people working on different projects, and it's a way of to do what we call shoulder surfing, so that you can just come up to somebody at a bench, and it's allowed. There's tacit permission given to be able to ask the question. Wow, that's a cool thing that you're working on. Tell me a little bit about it. So that's a way of building the community, but it's also part of just creating the good atmosphere within the space. So again, in terms of as we start to create the layout, we determine the program areas. So Makerspace Alzana is created as a very broad, multi-purpose, multi-function makerspaces. But we've done, for example, design spaces in Taiwan which are only focused on robotics. So they will have large CUDA arms, they will have embedded controller labs, etc. And everything there is designed around a single purpose subject in terms of robotics. But typically makerspaces are more broadly defined and tending to use people who can do things like textiles, ceramics, electronics, very, very sort of broad areas. So again, we try to build these different components. So we talked about the hard arts, we talked about soft arts. Storage, here in the area of support, storage is a huge problem. So somebody comes to the makerspace, they've got a project that they're going to be working on for maybe 2 or 3 weeks. You can't take it home every evening. It's at a particular stage of development. So storage of the project between work phases is a critical area. Textiles is absolutely fascinating. Textiles has traditionally been to the women on this call, my apologies, it's typically been a women's area, but more and more what you now see is men using the space, because they've suddenly had to start learning as their embedded sensors, as we're doing wearable technology, etc. They've got to learn to use these machines, and it's become much more usual to see men using these areas as well, and also learning the capabilities and the power, and also some quite often the skills that they have within these areas. The coffee area is the critical thing as well. You know, people are spending long periods of time in the makerspace, so you know, having your lunch, coffee time, etc. Again, it helps to improve on the whole social component. So, you know, people talk about, you know, one of the big questions we typically have with a client is, you know, how big is a makerspace? And I often ask, you know, well, how small can it be? We have designed spaces down to 30 square meters. That sounds really small, but you know, again, if you're quite specific in terms of what it is you want to do and what you need to achieve, you can do an awful lot within a relatively small space. Makerspaces though are also tending to get larger. As I said at the beginning, we're now looking at a space of about 4,500 square meters, which will be multidisciplinary, and that's an interesting challenge to program an area of that size and scale. Community, I keep coming back to this. The planners, our urban planners will often talk about placemaking, and within placemaking, what they're describing effectively is where we are in Alzane, it's typically a residential area, and in the planning component, they've done very much like it's done on the continent. They have shops on the ground floor. That's a standard kind of planning model. Shops and utilities on the ground floor, and then residential on the upper floors. What we constantly do in terms of working with planners is essentially say, okay, well, putting a makerspace in a particular location only works if you have a lot of the other support services around it. So people need to eat, people need to shop, people need people like lawyers, IP attorneys, you need couriers, you need a supply chain components all around. So we're trying to, as we create the space, again, thinking of the person who comes in the door. Who's coming in? Is it a child of 8 years? Is it somebody who's retired, who's in their 70s? Who are they? What are their needs? What are their demands? Are they going to come to us once only, or are we going to be seeing them for the next couple of years? So that community piece is quite critical. And I think, you know, for example, within TII, you have lots of different people. You have people from, you know, different nationalities, different languages, different cultural bases and references. So how do you build a community around that? And how do you apply that community around the projects that the organization is trying to do? So this is how we kind of go through the, you know, managing our community. So, you know, just some of the steps that we're working through. And, you know, very often what I'd like to kind of point out is that from an HR perspective, one very quick story. Google as an organization has a lot of highly functioning individuals. A lot of them, quite a number of them tend to be on the spectrum. And one of the challenges that Google had was effectively, how do you engage with somebody who's on the spectrum? They're fantastic employees. They are great when they apply themselves to the skills, but they tend to work as individuals. So what we developed for Google Plus in the US was a program where we brought in at the time up to 200 of their staff. They took over the makerspace for half a day. And essentially what we were able to do is create programs which took these people who were very isolated within their own day-to-day work, and essentially use the fun and that word that Milosh used earlier on, the fun of the makerspace to help them engage with their other colleagues and develop skills around that. So you can use a makerspace for lots of different purposes, and as I say, community is and creating a community manager is one of the most important parts. Let's also talk about gender. Typically, makerspaces in North America, where they originated, were very much male-dominated. You may have had maybe up to 5% of the population of users were female. The Middle East is completely different. You have 60% female participation, and the women that we see coming into the space, quite honestly, knock the socks off most of the men that are there. They are highly intelligent, highly educated, highly dedicated, and focused in terms of what they're using the space for. So there's an interesting case study to be done here in terms of why the female population is so strongly featured in the makerspace and why they've shone particularly in the time that we've seen them coming through to the store. Going back to the prototyping earlier on, one of the things that we keep promoting to people is this whole idea of design thinking. This is just a singular slide. We teach it in the schools. We talk to kids about, the idea is important, but you also need to figure out, how do you take the idea that's in your head? How do you define it, ideate it? How do you prototype it? How do you build your community around you? And it can be in terms of just, gaming, it can be in lots of different areas. But then as you come to a makerspace, that design thinking piece is, again, what is this piece that I'm working on the bench? How is it going to be used? How do I make it look interesting? How do I make it more useful to other people? So design thinking as a piece, as something to learn, is quite important, and it's a course that we're starting to run or will run shortly in the makerspace, because again, it's another part of that physical component that people need to take account of. So we've all learned lots of new things in the past year. It's been a very difficult time. Organizations have reacted in different ways in terms of people working remotely. How do you manage projects? How do you build things through? So we've been looking at how to integrate making into the workflow. In the same ways we talked earlier on about supply chain and getting stuff in from AliExpress and that, we're also been working, for example, in doing some of the schools programs with Emirates Post, getting kits out to kids, getting them to work remotely through Teams and Zoom session, sending us files, printing out the files remotely for them on laser cutters, sending the stuff back. So we found ways of working in the COVID environment, and I think we've learned a lot. We've learned a lot in terms of how to do stuff remotely, how to help people collaborate, and I think that again has powered a lot of making. People are doing pieces of projects remotely, finding different ways of working and integrating those components. And again, it's Milosh hit on it earlier on in terms of how you create the workflows, how you use the vendor chains, and I think again it's an evolving piece, but making I think is a large component in it. This may be a bit controversial in terms of what Milosh spoke about earlier on. There is a movement towards using desktop-based machines. You now have shown here in the top right-hand corner a desktop water jet cutter. So no longer do you need a 3 by 3 meter water jet carrying 10,000 gallons of water, you can do it in a much smaller space. Machines like the X-Carve down here on the right hand side, again, these are all tabletop machines. So I think what we're starting to see is that you have machines with a basic level of capability at a relatively low price point that people can start to use and work with at home or in the home office, and then graduate up to the Makerspace to use the larger bed sizes, to use the more capable software and machines. But there definitely is an issue and a change coming around in terms of these machines. I do agree with what Miloš talked about in terms of things like fumes in the environmental situation, but we are starting to see, as I say, Makerspaces into the home. I'm coming towards the end of the presentation, so let's just quickly talk about the fourth industrial revolution. There's a lot of buzz and a lot of hype about it. So maybe to give you a couple of just examples about what it means in reality. So let's look at IKEA on the top right hand side. IKEA in Europe is currently shuttering 50% of all of its warehouse space. So those big box stores that you see out of town in the large industrial estates, they're going to close 50% of all of that warehouse space. What they're replacing it with is CNC equipment, CNC wood lathes, metal equipment, engravers, and essentially they are going into a more customized model of furniture. So as well as designing your kitchen or your bathroom, you'll actually be able to go and say, okay, well, I don't like the regularity of the three doors. I'd like to laser etch a picture. I'd like to engrave an image on a piece of furniture, on a tile. And that mass customization route is where IKEA sees its future. So that's part of the fourth industrial revolution. If we look at Cisco here on the bottom right, and it's talking about smart cities. These are multi-billion-dollar contracts which cities are awarding all around the world. Cisco is one of the largest vendors in smart cities. The largest gating factor for them in implementing smart cities is enclosures. How do you put a $25 Wi-Fi or Bluetooth or UWB module into a refuse bin or into a bus shelter? They need, so when they go to that bus shelter, they may find that in the city there's 50 different types of bus shelters. Each of them requires individual types of enclosures. So they've been looking at Makerspaces and thinking, well, if we train people in terms of how to build the enclosures, can we, as we deploy in each city, use a Makerspace to customize those enclosures to facilitate these multi-billion-dollar contracts? Because without the enclosures, they're not going to sell the modules. So again, that mass customization, low volume, high value is really coming into focus with the fourth industrial revolution. And then as you go into the larger spaces and the really complex environments, what we're starting to see essentially is a move from DIY, which is what Miloš described, to a do-it-for-me environment. So what we anticipate will happen is that engineers will design in software their products. They will design their prototypes. They will be getting into much more complex materials, for example, titanium. They will be trying to design in up to 15 different axes. So that's not a skill that somebody is going to learn very quickly. So, and also the machines are going to be super expensive. A laser cutter, you can buy a very efficient laser cutter for, in the order of $20,000. Machines at this level are $150,000, $250,000. and a makerspace for the fourth industrial revolution could be anywhere up to around 50 million. So people aren't going to be able to learn to use the equipment, but they will start to be able to have shared access to these facilities, and it will become a more do-it-for-me model. So that's, I think, where we anticipate things happening in the coming years. And then finally, it's interesting in terms of how leadership has talked about, make it in the Emirates and this 300 billion dirham target. And it talks about, driving up the industrial sector, etc. But traditional manufacturing is gone. I talked earlier on about Australia and the way that it's performing. So I think there's a new way and a new route that needs to be found if the Emirates is going to be successful in this. TII, in what little I know of it, is providing one of those building blocks. If you look at other organizations like Tawazun, people in the defense industries, etc. We need to find a new way. We need to find a way in terms of these shared resources, and invent a model that's applicable to the UAE, that's going to work in the environment that we find ourselves in. And I think the coming years are going to be quite interesting and challenging in terms of how all of that goes together. So that's my presentation, and I'm very happy to take any questions at this point.
Thank you, Paul. Thank you for this very comprehensive outlook of what's happening outside the Emirates with respect to the Makers movement. So again, to all our attendees, I mean, you're open to write your questions in the Q&A or raise your hand. In the meantime, I have a couple of questions for you, Paul. One of them was partially solved already with one of your slides, but it came to my mind this question of whether I need or not a makerspace in my company, or I already use that one that is available in the neighborhood in the next quarter block. I don't know. So where to make the choice? I mean, where is the line in which I do need to secure equipment for my organization, or I shall use a system like this one so that the makeup movement keeps going on? You know what I mean?
Yeah. So there's no immediate answer to all of that, but let me give you the example of Ford. So the initial makerspace that we created for Ford in Detroit was essentially a shared space. So they have a very large campus, tens of thousands of employees. And what they wanted to do was create an environment where people from manufacturing, from distribution, from after sales could all come together. And again, I go back to this community. It became an point of intersection within the company where they could discuss projects, and they could, in the makerspace itself, start to work on each of those items. But that worked really well. And then, for example, what they discovered was, okay, well, how do you bring that closer to manufacturing? How do you actually help a particular process? So, for example, in Nanjing, in the facility that they run with a Chinese partner, the problem that they had was that if they found a problem on the production line, typically what would happen is, okay, they would note it, they would send it to engineering, and maybe in 4 or 6 months' time, the fix came back. But in the meantime, they had to constantly fix something, an ongoing problem, either, particularly because of a part or because of a production process on the line, waiting for the change to come through. So they said, okay, well, if we take Makerspace tools and we put them alongside the production line, let's identify what the problem is and let's work on it. The people who are there, who are deployed on the production line on a day-to-day basis, they know how to fix this. So the Makerspace tools allow them to come up with a fix and then go back to engineering and say, okay, we've solved the problem. Now you design that, you design the new part, you build it into the workflow. And what they found was that they were able to implement changes in less than a month. So from a cost point of view, from an efficiency point of view, that was fantastic. And that was deploying a makerspace where it was needed in the most appropriate place, but it didn't displace what they were doing elsewhere. For example, in Detroit and in the general environment. So I think it's a combination of both. And very often where makerspaces work really well is as a catalyst to design. We don't have the time to go into the stories, but what we often find is that what I talked about, the shoulder surfing idea, where you meet somebody in the makerspace and suddenly, I've learned that Milosh is fantastic at RFID. I loved all the SMA connectors and Raspberry Pi. So the next time I come to the UAE, I want to ask him a whole bunch of questions about some of the Raspberry Pi projects I'm working on. So it's that spark, it's that community thing adds real value. And also, for example, people like interns or university students, you may often, as a recruiter, HR people are, frequently visit the makerspace because it's a way for them to observe, university students at work. How do they apply themselves? Are they team players? How do they work with the technology? So I'll stop at that point. But you have to look at what does the company want to do. Sometimes it's useful to have maker tech equipment in the company itself, but it can become very tied to one department. Whose budget was this? Why is this person in there? They're not from this department. That's what you find in universities as well. That the equipment gets tied to a particular lab, and it's very difficult for other people. Again, in this multidisciplinary requirement, it's very difficult for people from other departments to come and use it. So the neutral space of the makerspace very often has lots of benefits for a company to be able to deal with that neutrality.
Okay. Well, there is a question by Felix, which I believe is very, very important. So he's asking whether you could give us your point of view on the intellectual property issues that might arrive when you start to use these kind of spaces. And this is very much in connection to our work, because we are dealing with research projects that are probably going to lead to publications or patents, So when you start to use a shared space and get the collaboration, the spark that you're mentioning, from others, which are not necessarily belonging to our company or our institute or whatsoever, that can become an issue. So I don't know whether you can comment on that. How have you been tackling this in the past?
Okay, so the best example again comes from the automotive industry, but it's BMW and Audi on this occasion. So the Makerspace in Munich is built on the campus of the Technical University of Munich, and it's partly funded by Susanna Glatten, one of the founder family of BMW. So she's personally invested within the creation of the Makerspace. So alongside the university students, you have people coming from BMW working on their projects. Ingolstadt, where BMW or Audi is located, is about 80 kilometers away from the Makerspace. And they started to use the Makerspace. So you had two competitors and all of these IP issues came up. So we started to analyze it with the IP lawyers from BMW, and they just wanted a blanket, pull down the blinds, lock the doors, nobody gets in here where the BMW people are involved. Long story short, essentially what they discovered was that if somebody is working on a piece of electronics, let's say a PCB board or a gear train of that, unless the engineer tells, the BMW engineer tells the Audi person what he's doing, what he's working on, you have almost no idea what that piece is unless you're told. Now, there comes a point in the process quite close to the end where you're powering it up or you're doing testing and that sort of stuff, where it becomes obvious to a trained expert what you're actually working on. but for 90% of the time, it isn't. So how we handle it in the BMW environment was that essentially there was a closed room that people could take things for final assembly and testing. That room is almost never used. And there has never been an issue of IP being taken. You have to be careful, but most frequently what you find is that the stuff it's like they talk about in the spy trade. You know, it's people talking. That's how you get information. It's rarely all what you see on the bench or the worktop, but you do have to be careful.
Well, and I can confirm, I mean, from my personal experience in different institutes, you usually want to talk to your colleague next door, and you never understand what he's doing. And
Yeah.
we belong to the same institute, and we are working in similar projects, and sometimes I just don't understand. So yeah, that kind of confirms the idea of what you just presented before is rarely a conflict there.